Assalamu alaikum. So this is for the experience. This is for your information on the safety measure for the lab. You need to wear all your proper attires, especially particularly your lab coat is very important, and the wearing of gloves is also very important, and the use of your mask are also important, especially during the COVID-19, which is around here. Then the wearing of shoes is a must. Before we start the experiment. Assalamu alaikum. This is experiment number 8, which involve the adsorption, involve the study of adsorption isotype. So basically, the adsorption isotype simply involve the study of the affinity of the activated carbon with the methylene blue. So this experiment, the following apparatus are going to be used for this experiment. We have 11 different conical flasks are going to be used for the experiment, and this is the methylene blue, and this is the activated carbon to be used as the adsorbent. So here are the cuvettes to be used for measuring the equilibrium concentrations. Now this is the paraffin to use. We want to use this one to cover each of the flasks to be used for the adsorption process. So first of all, what we need to start with is to introduce an initial amount of 100 ml of. So now we want to measure about 125 milligram of the methylene blue to be used for the preparation of the methylene blue solution. As we can see, the methylene blue has been prepared, and we want to pour into each of the bottle about 100 ml of the methylene blue solution in each of them. So using the measuring cylinder. So the next thing is that we want to homogenize our solution, the methylene blue solution, as you can see, for about 30 minutes. So the next thing is for us to weigh the different masses of the activated carbon, starting from 15 milligram. So the various masses have been weighed, and are going to be transferred into each of the flasks as to be as being labeled from 15 from that of 15 milligram up to 200 milligram. So now all the bottles are properly sealed with paraffin film and ready for the adsorption process. As you can see, the next thing is to go for the adsorption process. So all the beakers containing the activated carbon and the methylene blue are being placed in the on the shaker, as you can see. So we're going to turn on the shaker now at a speed of about 200 rpm, so for a particular period of time, in order for the adsorption process to reach equilibrium. So we start by turning on and set up the speed. As you can see, we on, so it has been turned up on, as you can see. So the adsorption process is now ongoing. We wait until it reaches equilibrium. So as we can see, this is going to be the sample, this is the sample before at the adsorption process, and this is how it looks like after it reaches equilibrium. So as it reaches this, we need the next thing is to measure the concentration, the concentration of the remaining methylene blue over here, which is going to be used to determine the particular isotope, whether it is the Friedrich isotope or the Langmuir isotopes. Meanwhile, those two isotopes are the most frequently used isotope in adsorption for the adsorption process. So we go. The next thing we go for the adsorption. For the UV testing now. Okay, student. Next, we are being asked 3 questions from our experiment, as previously explained. The first is that they say you should plot the data in a standard isotope format. Then, how do we plot the data in a standard isotope format? For the Langmuir and the Friedrich isotope, we have a standard formula we usually use for them. So the linearized form of the formulas are given below. As you can see, this is equation 1 and equation 2. 1 is for the Langmuir isotope and 2 is for the Friedrich isotope. So from this particular equation, as we can see, this is the linear form of the formula. First of all, for Langmuir, for example, here we have this one. For us to draw the graph for it, we have this one. This is representing the y-axis, and this is our constant, and this is mx, meaning that a plot of y against x is going to give us a linear plot. So from that particular linear plot, we find the r-square value. We determine the r-square value, of which from that we can easily calculate our various constants. For example, the Qm is a constant, and Kl is also a constant. So those are the basic 2 constants we need to determine from the Langmuir isotopes. So now, as we can see, okay, initially this is our initial concentration, the C naught. First of all, for us to plot this graph, what we need to understand is that we need to know what the C naught. We are going to make use of this equation because you need QE, which is the adsorption capacity of the the adsorption capacity of the adsorption process whereby the C naught is our initial concentration, which is 125 milligram per liter in each of the solution, while CE is the equilibrium concentration after the final adsorption process. So in this, meaning that in each bottles we need to determine the CE after the adsorption process. So after determining the CE, then we need to determine the QE, which is the adsorption capacity of the adsorption capacity after the adsorption process in each of the flask. So QE is equal to C naught minus CE multiplied by, we have our volume. The volume is also constant, which is 100 ml. You need to convert this 100 ml into liter. You divide it by 1000, you get 0.1. While the M, the mass, is the mass in each of the flask, which we need to use. So after determining the value of QE, so these are the various things I already explained. So after determining the value of QE, then you can easily plot your graph of the for the Langmuir isotope. So as well as for the Friedrich isotope, which means in the Friedrich you can see this is going to be your Y, and this is going to be your X. So you plot Y against X, and then from the plot you can easily determine the value of N, which is a constant of the Friedrich, and the value of Kf, which is also a constant of Friedrich. So I think I've been able to explain all these two, because they say you should determine the constants. Now the third one is that they say you should discuss the experimental data of the Langmuir and the Friedrich isotope. So how do we define the various isotopes? By after you have what do you call it, your R square value, it can be easy. It will be more easier for you to determine whether the Langmuir is better fit your adsorption process, or the Friedrich is the better fit, in the sense that the R square value that is closer to 1 is going to be the best fit for this particular isotope. So from this you can easily derive whether it is a monolayer, or whether it's a monolayer or a multi-layer adsorption process. This simply defines the interaction of the methylene blue with the activated carbon. So I think in case of any question, you can contact me. I think that's all.